Welcome back to the next one. We have electric generator. So as I said the previous video, the principle of electric generator is electromagnetic induction and Fleming's right hand rule. By using Fleming's right hand rule, we can identify the direction of induced current. Okay. Now move on to the topic directly. Here we have one coil. Okay, this is the coil we have, and this is the rectangular coil ABCD I named as, which is placed between the poles of magnet, north pole and south pole. This coil is connected to the breast 1, okay, and the other side of the coil is connected to breast 2. Okay, here I have used two rings, first ring and second ring. This is the first difference in diagrams in electric motor and generator. In motor we have used two clamp, right? C-type clamp, which is not touched with each other. But here we are going to use one complete ring, and second ring also we are going to use, right? And note down here the brushes are connected in the first ring and the second ring, not in the same ring. These kind of mistakes you will do while you people are going to draw this diagram. So the brush 1 should be connected in the first ring, brush 2 should be connected in the second ring. Okay, and this one is axle. So as I said, this is the axle, it can rotate freely. Okay, and these brushes are conducting one, right? So these brushes brush is pressed with this ring, so it can rotate along with that ring, right? It's clear? These brushes are pressed with that ring and it can move along with that ring. And here also this brush is pressed along with that ring, it can also move along with this ring. Now the one side of the brushes is connected to the galvanometer, the other side of the brushes is connected to the another side of the galvanometer. Now what will happen in the sense, we are applying some magnetic field for this coil. If you are applying magnetic field for a coil, what will happen? The current is induced, right? That induced current, how it will be in the sense, we have the arms, right, AB, as well as we have CD, right? This arms AB will moves up and the arm CD will move down by using Fleming's right hand rule, not left hand rule, right hand rule. This is the direction of applied magnetic field and this is the direction of current flowing, induced current flowing. Then the motion of this conductor becomes Z direction, third dimension, right? Okay, so initially the AB arms moves upward and CD will go downwards. And meanwhile, this ring is rotating, right? The first half rotation, these brushes will come to this side. And the second ring, this brush will come to this side. So now what will happen? The polarity of the current will be changed, right? So the first case, the current is passing from, the induced current is passing from brush B1 and ABCD and B2. In your textbook they are given very clearly, this means the external circuit is, the current is flow from B2 to B1. That this one is external circuit. Okay, and that external circuit, the current is passing from B2 to B1, right? And once the half rotation is over, the second half rotation, what will happen in the sense, the current flow direction started from DCBA, right? The first half, the induced current flow in the direction of ABCD. After the second half rotation, the induced current will flow from DCBA and reaches here. Again it goes. The polarity of the current is changed, the direction of current is changed. Therefore, in that galvanometer, the first time the deflection will shows in the one direction. If the direction of the current is changed, what will happen? The deflection shows in the opposite direction, right? So this is, I have written here, the first half rotation, AB moves up and CD moves down, and the induced current flows in the direction of ABCD, which is explained by our understanding by Fleming's right hand rule. And the external circuit, current starts from brush B2 to B1. In your textbook they are given B2 to B1. And in the second half rotation, AB moves down and CD moves up. The induced current flows in the direction of DCBA. and the external circuit, the current is flow from brush B1 to B2 in the second half rotation. And this type of generator is called, we are saying that AC generator. It's changing its direction of current. The polarity of the current is changed. That's why we are saying alternating current. The current is varying, right? Suppose if you want to need DC generator, what we have to use? We need to use a split ring, right? In that split ring, the split ring will be acted as commutator. Try to understand my words. If you want a DC generator, we need to use split ring which is acted as commutator. In that, these brushes are fixed. It will not move, right? These carbon brushes will not move. This is fixed at that commutator. Therefore, there is no change in the polarity of current. We will get the current only in the single direction. That's why we are saying DC current or unique current. Unique current, right? DC generator also we can say that unique current is the current flow in the one direction. But in AC generator, the current flow in two ways, up and down, right? Can you say about what is your current you are receiving from your EB line? Yes, of course, we are receiving AC generator. What is the frequency of AC? What is the frequency of AC? 50 Hz. Per time it will vibrate 50 times. Then how many times it will be varied? Time period 1 by 100 second. The frequency of alternating current is 50 Hz. How many times it will vary in the sense? 1 by 100 times, because 1 second it will vibrate 50 times. 50 times we have 1 up and 1 downward direction, right? 2. Therefore 50 into 2 we will have 100. Therefore the time period is 1 by 100. We have the relation between time and frequency is time is equal to 1 by frequency. Again I am saying time is equal to 1 by frequency, right? So the frequency is 50 Hz. So in that frequency we will have 2 times is the current is varying. So how? So like the way we will have, this is one oscillation, this is for one direction, this is another direction. Similarly, if you are constructing for 50, for 2 it will becomes 4. So that's why I am saying 50 Hz and the time scale is varying 1 by 100 second. Okay. And one more point we have, why we need to take an advantage of AC over DC while transmission. Why we need to transmit only AC, not DC. If you are using DC current, it must give much power of loss. That's why we are transmission or line, we are passing only the alternating current. Can you? So if you are passing DC current in the transmission line, we will get lot of power losses. That's why we are going to transmit the lines of alternating current, AC current, because of it has a frequency of 50 Hz and varied with 1 by 100 seconds, and it will not have much energy loss in alternating current, right? I hope you understand well. Thank you. See you in the next video.